over Chapter 2 review, which we'll be going over what we went over on Wednesday over the Chapter 2 review. A couple of the questions within that some of you students were having concerns about, and I figured I'd make a few visuals so you guys could maybe understand the concept a little more. So one of the questions is, what is the element versus the compound versus the substance versus the mixture? Does anyone know this off of the top of their head? Do you guys, any of you remember what element is? Yes. Correct. Anyone know what a compound is? Multiple elements together. And so that'd be like sugar. That can be broken down into carbon, hydrogen, and oxygen. So that's a compound. That's sugar, table sugar. Yep, that's what C6H12O6 is. Now substance. Does anyone know what a substance is? Or like a pure form of a matter. So yes, it could be a liquid. It just depends if it's pure or not. Elements and compounds are classified underneath a substance. So some pure substances are sugar. Yep, you just said water. Yeah, that'd be one. Baking soda, copper sulfate, protein crystal, salt, and then tin, sulfur, and diamonds are a few examples of pure substances. Anyone know what a mixture is? Yeah.
A bunch of different substances mixed together.
Correct. And they can be two different ones, can't they? What are they? Genius, yes. So this would be an example of homogeneous mixture because it is coffee and it's all the same throughout, right? And then Lucky Charms would be an example of a heterogeneous mixture. So yeah, like I said earlier, you can break this down into a web if that makes it easier to understand the content. So you can say, oh, is it a form of matter or not? Can it be separated into simple substances, or is it uniform throughout? And you can kind of create a table if that helps you mentally see how they're related and how they're different. So now we're going into what is viscosity. I will need 3 volunteers. Colton, you too as well. So I have 3 substances on the counter here. This is water, this is syrup, and this is honey. And I have 3 dimes here. And I want you guys, you front 3, to watch closely. Well, all of you, but especially you front 3. And now you'll hold them and you'll drop them in when I say go, okay? So everyone drops them at the same time and we can see which one falls the fastest and which one goes the slowest. Ready? 3, 2, 1, go. What's the front row see?
Hasn't even made it to the bottom yet, and I can't see the bottom.
Yeah. So technically, we're showing that the viscosity is. Does anyone know what viscosity means? Do you guys remember? How it is? Yeah, how much friction it has.
Yeah.
So the resistance of its flow. And so water shouldn't have really any, should it? It should be pretty quick. Versus honey, which is very dense, a very thick compound. So, yes, those are how we can understand viscosity. What other materials could we have used to maybe see this? Could we have used hand soap? Does anyone else think of any other examples of things we could have used versus honey? Sure. Jello, yes. Molasses. Yep, that would have been a good one as well. So, yeah. You guys are welcome to sit back down now, but I just figured maybe we could visually see viscosity and like what it's doing. It's fighting against the friction of the substance. So this is more or less viscous than the water. The honey is more viscous. So if it takes longer to get to the bottom, it's more viscous than the other. So now we'll go to, suppose you're looking to find the material of an object without changing the object's appearance in any way. Would you use the physical or chemical properties to figure out physical? Exactly. Now, how would you do it with this pan here? How might you be able to tell what substance this pan is made out of if you're just seeing? Um, hit it with a hammer. What about could we maybe find how rigid the material is, how malleable it is, so how flexible or not. What about um, what are some other things we can do? Anyone else think of anything? Um, any of you have to what? Look on the label. That is true. I don't know. I'm saying without looking on the label though. Like if you were given this, and you're like, okay, is this cobalt, zinc, iron, what? Yeah, the field. You can also find out how much electricity can pass through it. We can figure out what type of metal it is based off of that, off its anode and cathode. Um, Another thing we can do is we could see if a magnet sticks, right? Because iron sticks to magnets. So if we stuck this with a magnet and it stuck, it's iron, exactly. And that's actually what it is, it's a cast iron skillet. So now, I, there, sorry. I've got two clear liquids on the table. Now the same density. With just this information, is it possible to conclude that these two liquids are of the same material? No. Exactly. What would you want to just drink this thinking it's water without knowing for sure? No, right? Because it could be any acid that's clear. It could exactly. So if I were to want to try to taste one of these, what would I want to do first to make sure that I knew the substance and what it was made of? Smell would be one, yes. Maybe I could do a dip of acid base reader in there and see if it's acidic or not. You know what I'm talking about? That you can see the colors change. Exactly. So I would want to do multiple things before I chose to just drink this. Now I'll let you know one of these is vinegar and one is water. So, uh, nope, the right one's water. This one's vinegar. Yes, they do look the exact same.
I did think the right ones, but it was something else.
But yep. So do we have any questions on the material we covered? Let me go over a couple questions. So, um, what makes the substance viscous or not? Yes, and its resistance. And its resistance to friction. Good job, Reckon. How can you determine whether you're supposed to use a chemical or physical object? Correct. And then should I ever just guess that these two look like? Okay. So, good job, class.